Okay, so polar coordinates and complex numbers. This is the unit review. I'm just going to start from the top, but see how many problems I can get on one video here. The first question you're going to be asked on the test is to graph a point in polar coordinates. Now remember, really, when you're dealing with polar coordinates, all you are looking at is, like, here's your pole is what we would call the origin in rectangular coordinates. And everything is in relationship to that. Our R is how far we're going out, or our radius, and theta is the angle that you're going to go around to. So you can kind of think of it as out and around. So point A here, my R is -2, my theta is 5 pi over 6. So if we go over to 5 pi over 6, 5 pi over 6 is this angle line. But we need to go the opposite direction of it, or in the negative direction. So we're going to go 2 on that angle line in the other direction. That's how I like to deal with the negative. So if you kind of think of around to your angle and then go toward it or out that angle if you have a positive, and in the opposite direction if you have a negative. B is a little more intuitive. 4, 2 pi over 3. So if we go to our 2 pi over 3 angle line, which is right here, we're going to go out 4 on that angle. Make sure you're labeling your points so I know you know which points you're plotting. Last one here, C, -pi over 4 is our theta, -3 is our R. So -pi over 4 is going to graph clockwise. So it's that angle line right there, but we're going in the opposite direction, 3. So 1, 2, 3. So there's where C is going to go. You don't have to have all of those little dotted lines. I just did that for a visual to help you. All right, so that's plotting points in polar coordinates, R, theta. To find rectangular points for polar coordinate points, so here we're just going back and forth for the next couple problems from rectangular to polar, and then for number 3, you're going to go polar to rectangular. Rectangular to polar is easier. It's the easier direction. Remember, you're going to have that equation sheet available to you, and that equation sheet tells you if you're going from rectangular to polar, x, and remember, rectangular coordinates is xy. Polar coordinates is r theta. So if you're given polar, to get to rectangular, x is r cosine theta, and y is r sine theta. And I've done my best to give you nice ordered pairs where you can find some good points here in exact form with your unit circle knowledge. So here, r is 3 and theta is 7 pi over 6. So for A, x is 3 cosine of 7 pi over 6. I'm going to go ahead and keep working with x here. So I know it's going to be 3 over 1. So I know that my cosine of 7 pi over 6 is a fraction. And since it's a 6th, cosine is radical 3 over 2. And since it's in the third quadrant, it's negative. So my x value here is -3 radical 3 over 2. Y is r sine of theta, so 3 times sine of theta, or 7 sine of 7 pi over 6. So that's 3 over 1 times, at all my sixths, sine is 1/2. And in the third quadrant, at 7 pi over 6, sine is negative, so that's -3/2. So in rectangular coordinates, this point is -3 radical 3 over 2, -3/2. Use the equations. All right, next one. Again, same equations. X is r cosine theta, y is r sine of theta. So here x is r, which is -9, cosine of 4 pi over 3. So that's negative 9 over 1. And cosine of 4 pi over 3, at the thirds, cosine is 1/2. At 4 pi over 3, cosine is negative, since that's third quadrant again. So this is positive 9/2. Y is our sine of theta. So negative 9 over 1 times negative radical 3 over 2. 3. Not the prettiest points in rectangular form, but it works. All right, last one. You can also sketch these if you're feeling uncertain about if you have the right final answer or not, and make sure at least you're in the right quadrant. So back here at 3, 7 pi over 6. 7 pi over 6 is a third quadrant angle, and you'd be going out 3. So it makes sense that you have negative in rectangular coordinates. For B, when we had negative 9, 4 pi over 3, 4 pi over 3, again, is a third quadrant angle, but negative 9 would take us in the opposite direction. So it does make sense that we ended up with two positives, our positive x coordinate, positive y coordinate, to put us back in that first quadrant. Okay, negative 5 pi over 6. If we do a similar little sketch here, negative 5 pi over 6 puts us in the third quadrant, around here. But then negative 5, again, we're going to go in the opposite direction. So our final answer should end up as a first quadrant rectangular coordinates situation. We should end up with positive. So let's do the math and make sure it works. Again, x is r cosine theta. And if you'd rather work with that positive angle, negative 5 pi over 6 is the same as 7 pi over 6. And we already did cosine of 7 pi over 6. It was negative radical 5 over 2. And there we ended up with a positive x coordinate, which is what we expected. And here, sine of negative 5 pi over 6, again, that's the same as sine of 7 pi over 6. It's negative 1/2. And it's positive. So that's the same as 5 radical 3 over 2, 5 halves in rectangular, positive. It's a good double check. It's good to use your unit circle knowledge and your knowledge of polar coordinates to make sure that your answer is reasonable. All right, I think that's enough for the first video. I'll do number 3 on the next video.